Ever built a mobile app and watched your stunning, pixel-perfect interface completely shatter the second it loads on a different screen size? Yeah, it's incredibly frustrating, and we've all been there. Welcome to this explainer. Today, we're embarking on a metaphorical construction project. We aren't building a physical house, though. We're engineering a mobile app interface from the ground up using Flutter. If you've ever looked at a beautifully complex app and wondered how the architecture actually holds together under the hood, you are absolutely in the right place. We're going to break down the technical blueprints, focusing heavily on the deep composition of widgets, structural layouts, and interactive gestures. By treating this like a true construction site, the underlying mechanics of declarative UI are going to become incredibly clear. Let's get into it.
So, what's our ultimate architectural mandate for today? Well, it's simple but highly ambitious. As you can see, our core mission is to make you able to apply common widgets, build a high-level view of layouts, and seamlessly apply user gestures. Think of this as your master blueprint. We have to go from assembling basic static components to organizing complex, responsive screen grids, and finally, the best part, wiring up those elements so they instantly react to user input. Transitioning from a pretty, static rendering to a living, breathing interface that manages state gracefully, well, that's often the hardest part of Flutter development. And that is exactly the gap we're bridging today.
To get there, here's our roadmap for this explainer. First up, the Flutter UI toolkit. Next, architecting your app layouts, followed by adding interactive user gestures. And we'll wrap the whole thing up with the Master Builder Blueprint.
All right, moving right into Section 1, the Flutter UI Toolkit.
Let's crack open that toolkit and look at your raw materials. Here are the atomic widgets. These are literally the bricks and mortar of your mobile app. But in Flutter, you don't just drop these onto a blank canvas. Basically, everything is a widget. Your safe area, your app bar, your containers, they aren't just standalone UI elements. They are classes that compose together in a deeply, deeply nested widget tree. The real trick here isn't just knowing that a button triggers an action, right? It's knowing exactly how to nest these components perfectly within columns and rows to get that pixel-perfect render. Whether it's a rich text format, an interactive form, or an image, every complex app you use on a daily basis is fundamentally just a massive, meticulously structured tree of these exact raw materials. Now, taking those raw tools and actually turning them into a functional app requires a strict, sequential three-step plan. First, you design the UI by explicitly structuring those common widgets. Second, you focus on user input by creating an interactive form. And third, you step back and design the overarching app layout. Skipping step 1 and jumping straight into complex layouts, honestly, that's a common pitfall, and it inevitably leads to some serious spaghetti code. You really need a structured, disciplined approach to ensure every single widget fits perfectly into the broader application state, without causing those dreaded render overflows.
Moving right along to Section 2, architecting your app layouts.
Because let's face it, having a giant pile of great widgets is practically useless if you don't know how to structurally organize them on the screen. There's a massive conceptual shift between applying basic UI components and building a high-level layout architecture. Think of it as the difference between common widgets and layout widgets. Common widgets are the visible pieces, the text, the buttons, the icons. Layout widgets, on the other hand, are the structural architecture. They are your invisible scaffolding. In Flutter, the golden rule of layout, and you should definitely memorize this, is constraints go down, sizes go up, and parents set position. Layout widgets enforce these exact constraints on the common widgets. They dictate precisely how much space a button gets, or how an image scales when the screen rotates. Truly understanding this invisible scaffolding is exactly what separates a novice from a master interface architect.
So, to draft this blueprint effectively, your workflow involves 3 distinct conceptual phases. First, you need a high-level view of your layouts. You absolutely must visualize the entire screen's grid before you write a single line of code. Think about trying to build, say, a complex financial dashboard. If you don't visualize the high-level grid first, you end up with overlapping text, terrifying overflow errors, and an app that basically looks like a modern art disaster, with everything piled up in the top left corner. Second is the actual process of creating the layout, putting the framework up. And third is mastering the specific types of layout widgets available to solve those highly specific spatial problems.
Okay, Section 3, adding interactive user gestures. The structure is built, the scaffolding is up. Let's add the electricity.
Bridging the gap between a static, lifeless design and a dynamic, engaging user experience requires mastering one key thing: the gesture detector widget. This is an incredibly powerful, non-visual tool utilized specifically for setting up user interaction. Instead of trying to have buttons handle all your logic,
Gesture Detector wraps around other widgets in your tree and just quietly listens for touch events. Whether you need a user to physically pan an element across the screen or pinch to scale an image, this widget captures those physical screen touches and translates them into digital actions, all without bloating your visual code. It is, quite literally, the silent engine of interactivity.
And to truly supercharge that interactivity, you're often going to find yourself implementing draggable and drag target widgets. Imagine building a complex digital puzzle, or maybe a drag-and-drop inventory system for a game. You want the user to press on an item, making it draggable, and move it to a specific drop zone, the drag target. But remember, this isn't just some clever visual trick. Dropping an item successfully requires a profound state change in your app's back-end logic. Mastering these widgets effectively bridges the critical gap between front-end UI and complex application logic. It makes the digital world feel tangible and instantly responsive to the user's actual hands.
Finally, Section 4, the Master Builder Blueprint. Let's look at the ultimate rubric for a master builder.
Notice the really clear evolution of a developer's skill set mapped out here. You don't just stay in the fundamentals column forever. In the beginning, on the left, you're applying basic tools like safe areas and rows, identifying simple gestures, and recognizing the limitations of your layout toolkit. But true proficiency, that requires a massive leap over to the right side. Proficiency means evolving to master diverse layout architectures. It means moving way beyond simple taps to utilize complex tools, like Draggable, to create truly immersive experiences. Ultimately, it means demonstrating absolute mastery in navigating Flutter's deeply nested widget tree so you can reliably implement intricate, highly dynamic designs.
But wait, there's a catch. Ultimately, a true master builder doesn't just code blindly. They are expert communicators. It's one thing to interpret technical UI documentation to build your own features. We all do that. But as you reach high-level proficiency, the real test is whether you can produce well-structured UI design documentation yourself. Can you take your complex widget trees and interactive logic and abstract them into clear, readable blueprints? You have to be able to draw the map for the next engineer who joins your team, ensuring the architecture outlasts your immediate involvement. It's an absolute game changer.
So, you now have the architecture, the toolkit, and the electricity to build some absolutely incredible interfaces. But we all know the mobile landscape shifts daily. How will your layouts adapt when a user suddenly switches from a tiny, compact phone to a massive foldable tablet? How are you going to handle designing responsive user gestures for increasingly complex, self-learning scenarios? Keep these questions in the back of your mind as you continue your journey into app development. Keep experimenting. Keep exploring, and most importantly, keep building.